So I'm writing this little Simon game, and I found a challenge is getting the user response to the buttons. It would seem simple, right? While the button is pushed, turn the light on, you know? How hard can it be? Or maybe I should say, if the button is pushed, turn on the LED. But I found that it's not quite that simple. So here's some of the problems with reading the buttons. Yeah, I want to register one click. Even if the user holds it down longer, I only want it to register as one click. Another problem is sometimes the button bounces. Like you think you push it and you let go, but at a very fast, if you looked at it with an oscilloscope, it bounces a little bit. It's not a nice clean on and off. And the Arduino was so fast that it might register that bounce as multiple clicks. So I can't have that. Another thing I don't want to do is have long delays. So I can't have the user push the button and then delay a second like we did for other sketches, because we want to have a quick response in the game. So we don't want to insert a lot of delays to slow it down. So let me show you some of the things that I tried. So here's one where I use a while loop. So while the button is now it's called low, because I'm the way I've wired it up, the button puts the pin in the low voltage state. So while it's low, I do this stuff. And then I go on to the next one. So basically what we're doing a quick while statement. Okay, if it's not pushed, go on to the next one. Is button 2 pushed? Nope. Button 3 pushed? Nope. So it's a very quick loop that runs through. And then, okay, when the button is, or while the button is being pushed, we do some stuff. So let's see what happens if we run this. Let me plug this in and up. Put this code in here. Let me display my serial monitor if I need it here. Oh boy, where did I do with my... Here it is over here. Oop. So let me clear that out. So this is just testing these buttons. So if I push a button, notice what happened. See how fast it flashed? So while I push the button, it's still pushing the button. So as short as I push it, it's pushing it a whole bunch of times. So I'd have to do something a little more elaborate than that. But here's another attempt, is to say, using the if statement. So let's bring this one up. So here's one that says, okay, if. So I'm using if this. But this time what I'm doing, I'm setting a variable. Okay, if it was detected as being pushed, let's set a variable called a button state is true. So it's a Boolean logical variable that says it's equal to true, else it's false. So we do that for each one. And this is a very short, quick loop. And then down here, I do something with it. So if the button state was equal to true, we do this stuff. And if button 2 is true, we do this stuff. So the stuff is either set the pin 1 high or set the pin 1 low. Let's see what this looks like when we... So if I push up, so I have actually nothing in the serial monitor, and I didn't have any print statements. But see, okay, it works. And as I hold the button down, the light stays on. So that kind of works. Notice an interesting thing about this one, the way it works, I can actually push 2 buttons or 3 buttons. In any order, because it's so this would be a good thing to do if you had a control system where you wanted multiple things to work. So you don't want just one button at a time. You know, you got a nuclear control plant and you got different controls. You don't want to just change one thing. So if this is changing multiple things, this would work really good. But in my case, in my game, I just want the user to say, you're supposed to push button number 2 now, and he's got to push button number 2. Okay, well, let's try another one. This one I've tried. I think this has a lot of potential. What I'm doing here is I'm sensing for the opposite of what the button is. So if I set a button state variable, I got thinking what I really want to know is when is that button different. So the if statement test, I do a digital read and I say, is it not equal to the last button state? Now another thing I've introduced here is, okay, if it's different, so we're going to do, this stuff. So what we do, first thing we do is say the button state equals not button state. So we switch the button state from what it was. Now I inserted a delay statement with debounce delay. I set it for just a short number of milliseconds to get rid of that bouncing of the button. So when we push the button or release the button, either way, I want to put in a little bit of a delay so we don't read it right away quickly. So let's try this one. Did I push that code here? And bring up my monitor. So let's see what this does. So when I push the button, it says I pushed it, and I let go, it's released. So that works very well. And in fact, I think if I push button 1, push button 2, or button 3, and then let go number 1, I can actually do these in any order. So while I'm holding button number 1, it says button 1 pushed, I push button number 4, and then if I let go button number 1, so I can probably push 1, 2, 3, 4, and then release 1, 2, 3, 4. So that's kind of a nice way to do it if that's what I wanted. What I actually did in my program, that's not the one. Let's see. Yeah, that's the one. So what worked is I just check, is the button being pushed? And if it's not pushed, we just go to the next one. The next one says, okay, is button number 2 being pushed? Is button 3 being pushed? So this is a very short loop, runs over and over, checking for the button. So there's no extra delays in the loop to slow it down. So if all of a sudden the button is being pushed, then we go on to this stuff. This is what we do if this becomes true. So here's where we turn the pin on. We turn the little light on. And I just put a sequence as the button's being pushed. And then I delay for that little bounce delay just to make sure we're not sensing the thing twice. And then we have a while loop that's nested inside the if that's going to say, okay, I know you pushed number 1, but now while the button is still being pushed, I want to do nothing. So notice these little curly brackets with nothing in there. So this while statement is a while loop with nothing in it, but as long as that button is still being pushed, don't do anything. So let's try this one. Let's load this code in. And here's my serial monitor. Let me clear that out. So let's say I push button number 3. It says that button 3 is pushed. And then I let go. It says it's released. So if I'm holding button number 2, can I push? See, I can't do anything else because it's in that while loop. As long as I got my finger on that button, it's not going to let it go. So this is what I used in my program. Basically using an if statement to detect when the button is pushed, but then immediately going into a while loop. While the button is still down, don't do anything, just wait, you know. So that was kind of what I wanted in my program. So if you're interested, let's take a closer look at how I did this Simon game. So here's what I did in the Simon game. I used that method. So here's where I'm testing for button 1. So I say, okay, if the button is being pushed, first I define a variable called button equals 1, and I'm going to check that. Is that equal to, I have a random sequence and my counter loop. You know, I'm picking out one of those out of the sequence. Is that button equal to the one I'm expecting? So if it is, I set a variable called correct response is true. If it's not, I say correct response is false. Then we get down to the end, we can see, did the user make a mistake somewhere? So they get to the end of the loop of all these responses, either they finished the loop or they made a mistake somewhere, and correct response is going to be false, and we know, okay, they didn't win the game. But if they get to the end and correct response is still true, we know they finished the whole sequence successfully. And so here's where I'm saying while, just wait. And I just put a slight delay in there for that bounce delay, so that it's not really slowing down the while loop. I could have put that delay after the while loop, but it doesn't really matter. So just to kind of show you some of the things that we did in this game, just to show how it worked, let's go back to the top. So the first thing I defined is the maximum number of the sequence. So I got it set to 6, so it only play up to 6 times and say, you get them all 6 up, yep, you're the winner. You know, I can set that number anything up to 50, and good luck trying to get it right. That's very discouraging. So I'm going to set some maximum number here that's like doable. And here's my debounce delay I set. So I've been playing with that number. If I set it too low, sometimes I get double clicks, and that's discouraging to the user if they get an error that says you goofed, you pushed the wrong button, and they didn't push the wrong button. It was just that it bounced twice. Okay, there's some other constants and variables I define. And then another thing I did in this, I used some functions. So rather than inserting all of the stuff in here to play that little memory, little melody, let's download this code again into here. I call a function once, and then I have another function that flashes all the lights and does kind of a countdown. So that's my little countdown, and then it starts in the main loop. But before we get to the main loop, let me just go a few more things. So first thing I do is I'm going to generate a random sequence of numbers. Now, if you look at random numbers, basically what I'm going to do is I'm going to fill in. I'm going to do down here do a for loop, and we're going to fill up the sequence with a random number between 1 and less than 5. So it gives us a random number from 1 to 4. But what I did first is I did a thing called random seed. And what I did is I did an analog read of a pin that's got nothing in it. And that tends to return a random value between the 1 and 1023 because it just kind of floats in space. So I use that to seed my random number generator. The problem with the Arduino is if you just generate random numbers, they're a random sequence, but they'll be exactly the same every time. That doesn't sound like random, does it? They'll look like random the first time, but every time you run the program, you get the same sequence. Well, that wouldn't be much of a game, would it, if you had the same sequence every time? So I look at this analog pin to get a random number, and I seed the random number generator with that random number. Okay, so then we generate this sequence, and in the serial monitor I print that out. So here's where this, let me clear this and start this over so you can see. So I push the reset. Now, just before I pushed that, it generated this random sequence. Now, I've got it set to just 6 as a max count now, instead of something like 25, so it's easier to debug. And it's telling me, okay, the first number is 4, and it asks the user to enter the sequence. Now, the user wouldn't normally see this thing in the serial window. That's just kind of for debugging. But it helps me, as I wasn't paying attention, I can look and see, okay, what it's expecting is the button number 4. So I push number 4, and then it goes through the loop again, but with one more, and says, okay, now enter your response, and it's 4, 4. And then 4, 4, 3. But see if I get it wrong. See if I did 4, 4, 2. Right away I have it flash all the numbers to alert the user you got to the wrong thing, and then the game starts over again. So let's go back here, and so I using a for loop in an array. So the random sequence is this random list of numbers, and that's where I printed that out so you could let's bring that back up here. So that printed out this complete random sequence. Whoops, well, actually the complete sequence is up here. And see, then what do we do? And here's where we're actually just playing the sequence. And now here's the part where we get here where we listen for the user's response. So this is a debug print that says, okay, enter your response. And I start this loop over. So while I count is less than loop count, first thing I do is I turn all the pins, LED pins off. Now here's where I test for button 1 being pressed. And I say, okay, here's like I did before. If the digital read of button number 1 is low, means the button is being pushed, I do the stuff. If not, we just go on to button number 2. So there's our sequence. I do that for button 1, for button 2, button 3, button 4. Now it looks like a lot of code, but it's really not, because in the if statement, if that's not true, it just cycles through. So it's doing 4 quick if statements. So while the user is doing nothing, it's sequencing very quickly, testing each button one at a time. And then, so once the user pushes a button, we check to see, was it the correct response or was it the wrong response? And if it's wrong, here's where I just turned all the lights on so the user sees right away, oh, it flashes them all. Quickly I get a feedback that says, oh, you pushed the wrong thing. And then when the game is over, remember, if correct response is still true, we know the user got through the whole sequence and didn't make any mistakes. So we say, you're the winner, and then we play this happy melody. And notice again, using that function, I can just call the function. I don't have to put all that code in here again. So here's the function melody. Now, I don't know if we've talked about the word void. The word void means, well, this function doesn't actually return a value. Like, it's not like I call a function called the square root where I send it 4 and it sends me 2 back. Void means I'm not actually sending any return variables. So I won't go through that, but notice there's going to be some for loops in here, where we go through the notes. And then there's another function I call beep start, where it flashes. That's the one that flashes all the pins and it kind of changes the tone. I found that it gives the game a better sense that you're about ready to do something when all the lights flash. When I played a melody and flashed one light at a time, some people looked at it and thought, oh, is that the sequence I'm supposed to remember? So it's better to flash them all, then it's real clear that that's not the sequence. So that's the entire program. So basically we've demonstrated a digital read of buttons, a digital write to the LEDs. We've done an analog read to get that random seed number. We've used if statements to test the buttons, and then used a while loop to hold it. While the button is still pushed down, I want to just keep the light on. So let's show you how that works here. So here's the first one, is number 1. As long as the user holds that button down, it doesn't matter. It's just going to keep that light on and do nothing. But when you let it up, then it says, okay, let's go to the next sequence. And it turns out to be 2 of the same thing this time. So that's why I'm using a while. I've used Boolean variables, Boolean kind of logical, that are true and false, to keep track of whether did the user have the correct response all the way through. We've used an array way back at the beginning. I've just declared an array of let's see, the one I'm looking for is, okay, this random sequence of up to 50 numbers here. That's an array, or a list of numbers. And then a little later we're going to use a for loop to fill that array up with a sequence of random numbers. We've actually used the tone function. I guess I use that in several places, but down here in the, for example, in this beep start, what I do is I use the tone function to say what's the buzzer pin. Now I can show you that on, I should have shown you this. Here's in Tinkercad. You can get a better, clearer view of how I've hooked it up. This piezoelectric buzzer I've got hooked to my digital pin number 2, and the other side of the buzzer is just put to this ground rail, which is grounded here to the ground pin. So we've used the tone function, and that tone function here has what pin is it you're sending the tone out, what frequency is it, and for how long do you want to play that tone. Now it's not a very nice tone because it's really playing a square wave, not a sine wave, so it doesn't sound very, very nice, but that's what it is. And then I've used random functions. So those are some of the coding things I've used in the program. It was kind of fun to write. So that's about it.